Professional open-reel tape recorders consist of a number of components. Naturally, these include the heads themselves, the electronics for handling and processing the audio signal voltages that enter and exit the recorder for recording and playback, and of course the familiar transport controls. There are also mechanical parts, including the motors, the capstan motor and reel motors that pull the tape past the heads, and various guides that control the tape path, maintaining proper tension and head contact during recording and playback. Let's start by looking at the tape path as it's threaded through those various guides. As you can see in the diagram, the tape goes from the supply reel on the left to the take-up reel on the right. Along the way, it's threaded through several guides, including tension arms and rollers, and the pinch roller and capstan. The number and arrangement of tension arms and rollers is different on different machines. Sometimes there may be more of them, but the basic path is the same. There are also tape lifters, which move the tape away from the heads when appropriate. The tape is initially threaded through a tension arm and roller on the left. The tension arms help maintain proper tension to ensure the tape always stays in good contact with the heads during recording and playback. The tape wraps around the three heads and is then routed between the pinch roller and capstan. The capstan is driven by one of the recorder's three motors. As the tape is squeezed between the capstan and pinch roller, it's the capstan motor that actually pulls the tape past the heads. The other two motors are the supply reel motor and take-up reel motor. The take-up reel motor winds the tape onto the take-up reel, and the supply reel motor provides back tension, which, together with the capstan and pinch roller and tension arms, maintains proper tape tension. On the right side, the tape is threaded through another roller and tension arm, and is then threaded onto the take-up reel. Since tape is not a random access medium, you have to fast forward or rewind at high speed to locate particular spots. During fast forward, the take-up reel motor is the main motor pulling the tape, with back tension from the supply reel motor. During rewind, the supply reel motor takes over, pulling the tape backward with back tension from the take-up reel motor. During fast forward and rewind, tape lifters normally move the tape away from the reels to avoid the high-pitched chatter that would otherwise result, and to minimize excessive wear from contact with the heads during high-speed operation. In fact, the lifters typically keep the tape off the heads when the machine is not recording or playing back, but they can be switched to allow tape-to-head contact in stop mode for manual editing. I'll cover that later in the course. Naturally, the front panel contains the familiar transport controls: play, stop, record, fast forward, and rewind. On analog tape recorders, it's not uncommon to have to press play and record together to initiate recording. A tape counter helps in locating particular spots on the tape. Older or simpler machines may just count turns of the reels, while newer or fancier models are likely to provide readouts in real time, and sometimes even memory locations. Professional recorders also include panels of screw pot controls. These are for making the necessary track-based level, EQ, and bias adjustments that are part of the tape alignment procedure, which, for professional recordings, is done for every session. Again, I'll cover the alignment procedure in a later video. Per-channel meters indicate levels, both for alignment and setting proper recording levels. Older tape machines usually have VU meters, which, as you know, indicate average level. These are fine as long as you factor in the amount of transient peak energy that's not being shown on the meter. Newer recorders may use bar graph or peak meters, which should be more familiar to DAW users. But always keep in mind that, unlike with digital recording, analog tape has a maximum average level, 0 VU, that's typically around 10 to 15 dB or so less than the maximum peak level that DAW users are used to seeing on their peak meters. With digital recording, maximum average level and maximum peak level are the same, but that's not the case with analog tape, so it would pay for operators who came up in the digital era and are new to tape to pay a little extra attention to levels until they get used to this. Next up, we'll take a look at the various tape formats, from mono to multitrack.